Hi there, and a very warm welcome to this week's long tip. It's just a gut feeling, but I think it's a bit of a longer one. So this is the second part of our network rendering series, where we're going to take a look at C4D's Teamrender in conjunction with Octane, and all the tricks you need to do to make this a good experience. So since this is another technical one, let's grab your coffee and let's dive in. Here we go. This week's video starts out very similar to last week's, so we have our cutscene that we are going to render, but instead of Octane's network rendering, we are going to take a look at C4D's Teamrender. So we have a Teamrender server and a Teamrender client, and the web interface, here we go. So we take a look how to install it, how to manage it, and how to get Octane running on it. So let's keep going. Alright, small chart time here to show you the advantages of the team rendering compared to Octane's network rendering that we looked at last week. Small recap what Octane's rendering service is about. So we have a workload of different frames. Octane takes one frame, dices it into chunks, and then feeds it to the nodes. This has the advantage that all of the machines on one network can render on one frame, which can be good if you are only rendering one frame, but is bad when you're rendering animation, because there's constant back and forth between the server and the nodes to communicate what to render and what samples to send, which can lead to bottlenecking. Teamrender, in contrast, doesn't look at a single frame, but all of the frames and distributes them evenly to all the nodes. Which means very low network usage, since the scene is distributed with all the frames to every one of the nodes, so they can pick their frame range and render those individual frames, and therefore need no communication between the server and the node in the meantime. The only other part where there's a little bit of network traffic is when the finished frames are sent back to the server. Because the traffic is so minimal, of course we can scale our network much larger and therefore have the advantage of not running into bottlenecking anymore. Of course, this only works for animation, since every node is getting the whole scene and then just picks a frame or multiple frames to render. Okay, so now that you have a better understanding what Teamrender is doing, maybe you're more inclined to watch the rest of the video, so let's keep going. First good news of this video, so if you have installed C4D on your workstation, you have already installed the Teamrender server and the Teamrender client with it. So no more extra installations. Yay! For completeness sake, you can also team render in your C4D version without leaving it. You just have to go to your preferences, then find the renderers entry, team render, and enable it there. And if you go to your render menu, you can then team render to picture viewer. And this will allocate all the machines that are connected to your render. This is lacking some critical features as logging your output, so if C4D crashes while you're doing this, you have to start from scratch. So we're going to use the Teamrender server instead of this implemented function. Welcome to chart time. If you're not familiar with network rendering and the concepts, this is the right place for you. If you already know about that and just want to get into the technical bits, then you can jump to the next chapter. The concept is very easy to grasp, so we have a main workstation. This is where you have your C4D installed, and then you have another computer with capable hardware, and we wire those together. And so we call our main workstation server and the other one node or client. This of course is not only limited to one node, you can add another node and as many as you want, you just have to connect them via a switch. So we have a small network here. And basically we have to install software on the server side, which we already have done with C4D, and the node side to access the hardware here on the nodes and help rendering our scenes that we have prepared on our server. So since it's highly likely you have already installed C4D on your server, let's jump over to one of the nodes and install the client. Let's simply stick with last week's video structure and let's talk about licensing before we install anything to our nodes. So this time we are not only concerned with Otoy's licensing, but also C4D's licensing or Maxon's licensing, as we are using the C4D Teamrender. To find out more, let's hit buy and go down to one of those packages that include Cinema 4D, for example Maxon 1 or Cinema 4D and Redshift, and then go to plan details. And if you look at the fine print, you can see that every one of those licenses includes 5 Teamrender nodes. I let you in on a little secret here, so actually this is not enforced, so you can install as many Teamrender nodes as you want. You're just contractually bound to not install more than 5, so it's up to you what you do. So when it comes to Cinema 4D's Teamrender licenses, we're pretty much golden. But let's take a look at Octane licensing, because we have a little bit of a caveat here. As every Teamrender client pretty much acts like its own Cinema 4D version, you unfortunately cannot take advantage of the unlimited network rendering that Octane's licensing provides. So you need a full license of Octane for every one of your nodes. Dependent on your node count, this can increase pricing quite a lot, so it's upon you to decide whether it's worth it for you, dependent on the gain in control and stability that I will show later in this video that this workflow provides. Small side note, Otoy always had a Black Friday sale, so I guess this year is no different, and they always had massive discounts. So if you're planning in shopping for node licenses, this would be the right time. Alright, so let's prepare the installation on our nodes. So in this case, we need to install 2 software packages, one time Cinema 4D. So let's go to our account, log in, go to downloads, and then download the Maxon app or Cinema 4D directly. On Octane's side, as last week, we are going to our profile here, then go to downloads, and then since we are interested in a DCC plugin this time, we are going to download the Windows version of Octane for Cinema 4D. Here we go. Welcome to the desktop of our node. Now this is my production node, so I already have Cinema 4D installed. But let's talk about it. So basically you have 2 different ways to install Cinema 4D, either through the Maxon app or you have downloaded the executable directly. Since there's no download file for the Teamrender client, you always have to install the whole package of Cinema 4D. It is how it is. So just run the installation of Cinema 4D and then I'm going to show you how to install Octane, and it's basically the same what you already have done on your workstation if you worked with Octane before. So once we installed Cinema 4D, we need to open the install directory, so where the executable files live, and then also we need to double click on the RAR file. I'm using WinRAR, you can also use 7-zip. And I think you can even open it up natively in the latest Windows 11. I don't know about this for certain though. What we want to do next is create a plugin folder in the Cinema 4D directory if it's not already existent. So let's go right click, new folder. Yes, we want to do that and call it plugins. Here we go. Then dive into that and drag the folder from our compressed file over there and also allow it once it's ready. Now there's one more last step and you need to dive into that folder. This is our Octane version, and delete all the files that are not aligning with the Cinema 4D version that you're using. So this one here, 2024, we are using, so we're not deleting this. Here we go, and now we have successfully installed Octane for Cinema 4D. 2 side notes here. 1, always make sure you're using the same Octane version across your network. This is not checked by Cinema 4D, so you could end up with different versions. In contrast to Octane's network rendering, where the exact version is checked, Cinema 4D only checks whether there's a plugin installed called Octane or not. Second, since you're rendering with Cinema 4D over the network, all the other plugins that you use also have to be present on your render node. What that means in terms of licensing is really dependent on the individual developer. Some of them support unlimited render nodes, some of them only 3, for example Xparticles is one of those I think, and some of them have a license per render node. So you have to buy the plugin license for every node, similar to what we did with Octane. Okay, let's close our folders here and actually open our client for the first time. Before we move on to the Teamrender server, let's actually have a look at the Teamrender client since you are already here. If you opened the Teamrender client together with Octane for the first time, there's a good chance that you have been prompted to log into your Otoy account to validate your license. If this is not the case, there is a small trick to do that here, so you can go to File, Extensions, and then Cinema4D Octane, or whatever your plugin folder is called, and then go to the Octane settings. Now for me, this will activate Octane right now. For you, it might already have been activated. If there was no login prompt before, surely that should have done it now. So since you're already here, we can also set up your settings inside of the Octane settings here. So for example, if you don't want to use all the graphic cards and don't want to use RTX acceleration for some reason, you can set this up here. For me, this is all fine, so let's close that down and let's carry on. If you have your Teamrender client installed for a longer time and just wondering what versions of your plugin you have installed to match your network, you can just read the text here in the console. So this will tell you the plugin versions of all the installed plugins. For example, in this case, Octane 2023.1 R6. This is the latest to date. Since this is a network rendering application, let's actually have a look at the network rendering settings here by going to the Preferences, Renderer, twirl that down and going to the Teamrender. If that's the only client you have installed, basically you can leave it as is, but I usually do some changes to that. For example, I change the security token that is needed to connect to the server to another thing but the standard. So for example, render. And then the port name here is only important if you have multiple versions of the render client installed. That means I have a version for Cinema4D 2023 and a version for Cinema4D 2024. And if they're open at the same time, they will conflict through the port. So what I do is get the year number and set this to the end portion here of the port. So the 2023 version has the 23 and this version, which is 2024, has the 24. And this is all about that for now. So let's go back and have a look at the Teamrender server. Oh yeah, one more last thing. You need the IP address to connect to the client here. So you can find that there, but if you X that, there's nowhere you can find that inside of the console. But there is a option here in the view where you can also set it to be permanently turned on there. Small in-between chart time to explain the inner workings of the Teamrender server. So in contrast to last week where the server and Cinema4D was connected and therefore had to be run on your workstation, the Teamrender server is actually a solo application this time that can be installed to any machine that is connected to your network. While you can definitely install the Teamrender server on your own workstation, it is actually advised to seek out another node on the network that is not taxed with rendering to install the Teamrender server on. The reasoning behind that is very simple, so the node can run on its own and is not affected by any render-related outages, for example if your workstation is getting too slow and simply needs a restart. For very small networks like mine, I don't care if there's another machine or if it's my own workstation, so for me I have installed it on my own workstation actually. To make it possible to install the Teamrender server to a different machine, actually Maxon gone ahead and split the license into two parts, one part for Cinema4D and one part for your Teamrender, so you can split those out to different machines. Nice. The procedure actually would be the same as with the Teamrender client. You just install the whole bundle of Cinema4D and then just launch the Teamrender server and license this part instead of the whole Cinema4D package. Welcome to Teamrender server. So I am running my Teamrender server from the same installation as my Cinema4D on my workstation, so I don't have a separate machine for that. Small note, for those who have, you actually don't need to install plugins for the server, only the clients need those plugins. Speaking of clients, you can see that I already added some clients, but let's add one more. And actually this is a very special client since it will run on the same system as my server. Now, I talked about this before. If your server is capable of rendering, the NetRender server itself doesn't render, so you have to run the client on the same machine as well to get the rendering power. So let's do this and let's open up the client. Alright, so the client opened up, but it's not enlisted here. So to do this, let's click the plus button and we are prompted with the IP and port number of the client. Now you can read that here. So it's 10.20.20.110 colon and then 5424. And the 24 comes from what we said before. This is the C4D version number. So if I did everything right, now there should be the security token. Let's go with that. Here we go. And now we are entered and good to go. Also note that the server that is linked shows up in the client here. Alright, now that we've set everything up and all the nodes are linked to the server, let's actually come to the star of the show, which is the user interface here. So the user interface is actually a website that is distributed throughout the network. Right now we are using the home address, but this can also be accessed via the server address. What I mean by that is just the IP that the machine has the server runs on. For example, for us is 10.20.20.110. So let's go to our website here and try this out. 10.20.20.110. And instead of the server port, we need a different port, which is 8080. So this is the port for the website, and you can see this is exactly the same interface as before with the home address. There's a preset username and password, which is admin. I already stored that, so I don't have to type it every time I log in. Inside here, there are a couple of interfaces, so you can see all the nodes again that are currently online, and all the jobs that are there. There's none right now. And also you can get a little bit more info about the network. Usually if the clients do something, there's a log entry. Right now they haven't done anything since they started, so their log is not there yet. The only log we can read is that from the server. Okay, in the following, let's generate a job to render on our network. Welcome back to Cinema4D. Now let's have a look what we need to do to get this rendered in Teamrender. So since this is distributed to different machines with a different frame range, and we are coming to that later, this means that the CPUs of every machine can interpret stuff a little bit differently. So we need to tie down everything as much as possible. This means baking simulations or even keyframes. So let's have a look at our camera here. So if I move my camera, if I turn off rendering here, you can see it's a normal camera move, but it's a little bit organic since I used a vibrate tag on that to make it not as straight as just linear keyframes. Now if we go to our keyframes here, you can see those are still linear. Now usually that should work and give the same result on different machines. But sometimes there are different interpolations for different CPUs, for example, and therefore this can vary. So the best thing to do is to bake that down into keyframes. So let's bring up the timeline again, and there's actually a function for that. So if you go to functions and then bake objects with the camera selected, and then you can choose what you want to bake. So for me, I want to have a copy. I don't want to lose the original keyframes. I want to bake the position and the rotation. This is all I'm going to need. I don't need animated parameters. So let's bake this. Now we have a baked camera, and you can see the slight curving that occurs in all of those curves compared to the linear interpolation that the original camera had. Alright, let's close this down and go to our camera. It's marked copy here. So what we can do here is delete the vibrate or disable it, and then go to the camera with the depth of field. So we have our original camera that we are looking through with the baked keyframes, and now everything is fixed and can be sent to render. Obviously, if you have a larger scene than just with a vibrate tag, then you need to bake it down too. Fortunately, Cinema4D offers baking capabilities for MoGraph as well as the new simulation system. For those who follow my videos regularly, you know that I like to output my frames using the Octane output rather than the Cinema4D one. Unfortunately, this can lead to problems since Teamrender only knows about the Cinema4D outputs and not the Octane one. There are ways to work around that with sharing folders in the network that might be a little bit technical. So if you are not that technical kind of person, you can just go to the Cinema4D output, enable that with the image type you want to render, and then be good with it. So you can jump to the next chapter if you don't want to see me sharing folders in the network. What am I even talking about? So in general, the server sends out frames to render, and then the nodes pick them up. But every one of those nodes is basically a regular Cinema4D installation that is just rendering a frame. So there has to be a mechanism that the node knows, oh, I'm just a node, and when the frame is finished, I need to send it back to the server, which is included in the normal Cinema4D output because it's part of the Teamrender ecosystem, which Octane is not. So Octane is rendering the frame as if it was on its own computer somewhere in the network, and it doesn't care that it's in the network rendering for Teamrender right now. So when it saves the frame, it just saves it locally. So with the proprietary Octane frame output, what we need to do is set up a shared folder on our server that all of our nodes have access to, so we can put in the shared folder's network path into the Octane output, so all of the frames that are saved land there. So let's do this next. Welcome to Desert Land, or should I say Dune Land, since this is very dry. So let's go and share some folders. Now, if you have a network attached storage, this is your bonus. So you can mount that to every one of your nodes with the same drive letter and therefore use that as a path. As I don't have that, we are just going to make a new folder inside of the renders and then share that. So let's make a new folder here and call it Octane Net. Here we go. Then right click, properties, then go to sharing, and then I'd like to do the advanced sharing. So share this folder, you can change the name if you want. And then what I go to permissions and set full control because I want the nodes to be able to read and write from there. Okay, let's hit apply here and then OK. Apply OK and close. Alright, this should be already it. So let's see if this is accessible through the network. So what we need to do is go into the address line here, double backslash and then dark matter. This is my machine. And yes, you can see it is popped up here. So if we go in here, this is basically the path that is accessible now within the network and that we can copy here. So copy that, close that, and let's open up Cinema4D here again. And let's go to the Octane render output and paste in that path. Alright, to finish this up, there's one more last step we need to do. So this has to do with the save option here. And actually, even if there's no save tick here, it will be saved by Teamrender as a security measure. This is obviously to avoid rendering for nothing, so we always have an outcome. So right now we are saving two different OpenEXR files, so once in the Octane save and once in Cinema4D save. So what I want to usually do is set this to JPEG and on both of those outputs. Here we go. The good thing now is that Cinema4D saves a very small file size that we even can look at and see if the render has any errors, while Octane does its thing and saves the big EXR file here. When it comes to settings, so when we go back to main here, color space for example, you can set whatever you want, but OpenColor.io, you would need to set this up on every one of your nodes, so those have access to your OpenColor.io file that you've linked here. And if you don't want to have any more setup, then I say restrict yourself to the other options at hand. Let's do a last quick check. It's always good to do that so nothing goes away. So first of all, we have the right path here. Second of all, we have the JPEG set up in the Cinema4D save. Then also make sure the resolution and the frame range is the correct range. And once you're okay with that, we have to save our project with the Save Project with Assets command. So all the assets are gathered within the same scene file. Here we go. Let's go and save it just here in the main tutorial directory. Let's call it Octane Cup Render and hit Save. This created a folder with the name you just specified, and in there's everything you need to render the scene, namely the Cinema4D file and the assets, which are textures in this case. What we need to do next is upload this to our server so it can recognize it and then distribute it throughout the network. So what we want to do is go back 2 folders and then copy this folder here because we need to move it to the server. The best way to do this is by opening the render server here and go to the preferences and actually go to the preferences folder. So let's open up this one here, and basically you can see all my different Cinema4D installations. Also the C means client and the S means server. So we go in here, then go to the server folder, then to users, then to admin. Remember, this is the login also. And in here, we just paste in the folder that we just copied before. Here we go. So now when we open up the web interface, you can see the job is there. And if we go to jobs, then it needs to think for a bit, but then it will show the job here. And it has some data here where we can see that the frame rate is 0 to 100, so 101 frames. And that we haven't rendered it yet, and all the assets are there too. So let's hit render or start and see what happens. So this will prepare the rendering. Also, if we go to the network, all the render nodes here will get some population in the log, but we can watch this directly here. You can see the render client now downloads all the assets and then starts rendering. And this happens on all the other machines too. There's also an indicator here that those machines are right now active and doing something. Alright, seems like we did everything right, so I let this render for some time now and we can see some progress. And on the other side here we can see the folders that are populated or responsible for the rendering. So this is the folder we had for our Teamrender, so from there the scene got distributed over the network. And down here, this is the folder that we also shared over the network. So let's go in here and let's see what's happening here. And you can see, yes, Octane is actually populating this folder with the files that are rendered. And you can see there are small jumps inside of the sequence here, and this means they are coming from different machines, and therefore the network share is working. Now on the upper folder here, you can see that there are more folders inside now. So we started out with the Cinema4D file as well as the text folder. So now we have some ini files here as well as results and renders. And if we go to the renders folder here, you can see those are our JPEGs being stored there. There seems to be a path here, probably the alpha, that the Teamrender stores in a white JPEG, but since it's so small, it doesn't matter. We are interested in our beauty path, so if we double click here, we can check whether our render is looking good for all the machines, and it seems like it is. So we are all golden. Alright, let's go over some nice to know and nice to have features here. So basically the most nice to have feature is that the progress is stored. So if we restart the system, or if there's an electricity cut or something like that, and you reboot it, it will just start up with the range that is left. And this is in contrast what you have in the Cinema4D Teamrender. When you stop it there, you can never start again where you left off. It will always start from scratch. And this is one of the main reasons why I use the render server instead. Just to let you see that, this is probably stored in one of those files. So if you want to actually start from scratch again, then I would just suggest deleting all the folders that are there, that are newly created when you start the job, and then start the job from here again. Then it will calculate for a bit and then start from scratch. I just created a new job by just copying my old job. This is also a way you can do. And by changing, for example, the camera path inside of the Cinema4D file, you can iterate there and then real quick render another version. Also, if you start both jobs, you can decide which job has priority and therefore which job is run on all your nodes. You cannot dedicate nodes to different jobs. This is something that more expensive render managers can do, like Deadline, for example. The Teamrender server only can assign one job at a time. And I think that's about it. Let's go to chart time again, where we go about the pros and cons of the Teamrender server, which you probably already figured out by now. Let's end our long video by looking at the pros and cons of Teamrender. As Teamrender is a product of Maxon, it is included with Cinema4D. It is generally more robust for animations. In the principle, it works because it distributes frames and not splits them up like Octane. It has a web landing page overall your network, so you can access it from all the machines that are connected to your network and therefore access and manage it. It scales very linearly, so if you have multiple machines and add them to the network, this power is then added directly to your render speed. And one point I haven't made yet, so if you have set up your render network with the Teamrender, it also works with Redshift and all the other renderers that you might have. Obviously, it's not all sunshine and flowers, so of course you have only the suitability for animations. If you want to render still frames, single still frames, then Octane in this case is better to allocate all the power of your network on one frame. One very big caveat that is also costly is that you need a Octane plugin for every one of your nodes. If you have seen the length of this video, this is quite apparent that the setup process is more complicated for the Teamrender than with the Octane service we spoke about last week. And therefore also some networking knowledge is required to share folders over network or to attach your NAS to your nodes. Now the last point is only halfway bad. Since I had clients freeze and stop working, I had set up services that check on those and then revive them when they are frozen and restart them when the process is not detected anymore. This is only half bad because freezing clients only take down the one client. The rest of the network will still finish the job, so it's much less likely you get into the office in the morning and your job is cancelled. Usually the job is done because the remaining clients have finished it. So this is it. I hope you could take something away from it and learn something. Thank you very much for watching. And now let's thank our Patreons who made this video possible, such as my €50 tier subscribers, Gilles Augustinen and Leon Studio TV. Thank you so very much. I know I say this every time, but I really mean it. Also, a huge thanks for my €15 tier subscribers, AB Studio, Alessio De Vecchi, Alex Wilson, Bavana, BVR, Christian Grajewski, Computer Generated, Etienne Schmidt, George Luna, Harish Pavaskar, Troy Ciccoline, Just a Freakin', Chris Clemson, Ludger, Part 1 of 2, Kwok An Dang, Raiko, Reshock, Rory H., Shamus Johnson, Terry Wayne Renson, Yassin Rupp, and Shibuer Zhang. As always, if you're still with me, if you're still watching, thank you so very much for sticking with me that long. Lately, I noticed a lot of fluctuation with my patrons. I'm not sure whether it's the time of the year or if it's something that I can do to provide better usability. If you can think of something, please let me know in the comments. And while you're at it, you can add a spider web as a emoticon so I can see you watch till the end. Thank you so very much again. And with that, I'm wishing you the best of times, a good start into the week, and a classic happy rendering. Bye!